Hello everyone, this is your second video for Unit 4 Quadratic Functions. Notice you have a pre-class assignment, the square root property. Let's do 718 at midnight. Alright, application 1. This formula, negative 16t squared plus h naught, models the height in feet of an object t seconds after it's dropped. H naught is the initial height, and the negative 16 deals with how gravity affects us. That's where this negative 16 comes from. So if a water balloon is dropped from a rooftop that is 400 feet high, this function produces the height in feet of the water balloon t seconds after it's dropped. So this will produce the height t seconds after it's dropped. So what is the independent variable? Where the independent variable is time, and the dependent variable is h of t. What is the initial height? So h of 0, when time 0 is 400 feet. So the water balloon is at 0, 400. We'll call this 400 right here. So this is t, and this is h of t. When will the water balloon hit the ground? So when will h of t equals 0. So that implies I'm going to set this equal to 0 and solve for t. How do I solve this function for t? Well, I need to subtract 400. So that implies that negative 400 equals negative 16t squared. Then I divide by negative 16, which implies that t squared equals a negative over a negative becomes positive. And 400 divided by 16 is 25. But it's t squared is 25, so I have to square root, and I get t equals 5. So the water balloon hits the ground 5 seconds after it's dropped. So there's 5. So the water balloon does this kind of thing. Takes 5 seconds to hit the ground. Find the height of the balloon 4 seconds after it's dropped. So basically I want to find h of 4 equals negative 16 times 4 squared plus 400, which equals negative 16 times 16. So it's 16 squared. Equals 144 feet. So that's going to be, here's 4. So 200 is going to be about right here. So it's going to be a little below that. So notice it does fit right there in my graph. Even though I did it by hand, it all works out pretty well. What is the vertex of the parabola that was graphed in part B? It's right here. That's the maximum height. It's the point 0, 400. Because this graph, even though we didn't write it, the rest of the parabola would be over here. So the graph kind of does this kind of thing. But the only quadrant we care about is this one here where t is positive. What is the x-intercept? Well, the x-intercept is the point 5, 0. That means after 5 seconds, the balloon hits the ground. What is the y-intercept? Well, that's 0, 400. That means after 0 seconds, the balloon is 400 feet high. What is the relevant domain? The relevant domain is 0 to 5 seconds, and the relevant range is 0 feet to 400 feet. So this is initial time, time when it hits the ground. This is height when it hits the ground, and the initial height. So you notice that's graphed here. So our domain is from 0 to 5, and our range is from 0 to 400. What is the initial height of an object whose height t seconds after it is dropped is given by this function? So h of 0 equals 30 feet. So the initial height would have been 30 feet if that is the function. This function, what you have to be careful of when you're doing this problem, which this is one in your homework, so I'm not going to do it, but you have to pay attention to x represents half of this distance. So if a truck is 8 feet wide, that means this is 4 feet. So it's 4 out here to -4. So this would be an 8 foot wide truck right here. This would be 8 feet wide right here. So 12 feet high, so 2, 4, 6, 8, 10. Judging by looking just at the graph, it does not look like that truck would fit through this tunnel because it would hit here and here. So here you would let x equal 4 in this case, because h of x, where x is the distance from the center of the tunnel to the outside. Then we have a volume application. A volume of a can with height h and radius r is given by this. Pi r squared h. So pi r squared is the volume of this circle, and then you multiply it by the height. So pi r squared is the area of this circle, and then when we multiply it by the height, we get a volume. So let's answer. So identify and label the axes for this application. So we're going to set our height to be 4 inches. So our variables are r and v. So radius and volume depending on the radius. What is the volume of the can of beans if the radius is 2 inches? So v of 2 equals 4 pi 2 squared, which equals 4 pi times 4, which equals 16 pi, which is fine. You don't have to write that as a decimal. So you would plot that on your function. So this graph actually looks like this. When the radius is 0, the volume is 0. As the radius increases, the volume increases. So this point would be 2. We could call this 16 pi. What is the vertex of the parabola? Well, it's actually 0, 0. What radius will produce a bean can with a volume of 113? So we're going to go 113 equals 4 pi r squared. So we're solving for r, so we're going to divide both sides by 4 pi. And then square root. Then we square root both sides. We get r equals the square root of 113 divided by 4 pi, which is approximately, let's go to our calculator. Let's do 113 divided by, open parenthesis, 4 pi, 4 times pi, close parenthesis, equals, and then I'm going to square root it. So approximately 3 inches. 2.99. What is an appropriate domain? Well, the domain is going to be from 0 out to infinity. It never ends. So the domain of this problem goes on forever. What about the range? Same thing. It's from 0 to infinity. As my radius increases, so does my volume. So your applications 1 video has 2 questions that you need to turn in. It actually has 3 questions total, but 2 of them you need to create a Microsoft Word document, answer the questions, save it, and email it to me. And these application 1s are due 7/18 by midnight. My next set of videos, which I'll either make tomorrow or Thursday, will cover this factoring section and so on. All right, everyone. Thank you and have a wonderful day.